We're going to look at problem number 13. So problem number 13 tells us a motorcycle traveling at 25 meters per second accelerates at a rate of 7 meters per second squared for 6 seconds. What is the final speed of the motorcycle? So they ask us, what's the final speed? We're going to find velocity. So we'll call that VF. Our time is 6 seconds. So that is our delta T. And it tells us it accelerates at a rate of meters per second squared is our acceleration. So we can see it two ways. It tells us it accelerates at this rate, and it also gives us meters per second squared. Our motorcycle here is traveling at 25 meters per second. We know this is the final, so this has to be the initial. So our given VI is 25 meters per second. VF, we don't know, so that's what we're trying to find. A is our acceleration. It's positive 7.0 meters per second squared. And our delta T is the change in time, which is 6.0 seconds. Okay, for our diagram, we have our motorcycle. Okay. Good enough, right? There you go. Or actually, here we go. Look at that. Motorcycle. Sorry, hold on. There's the handlebars. That looks like a kind of, I don't know. All right, our diagram. Our initial velocity is going to be the starting velocity. Our final velocity is unknown. We know that it's accelerating at 7 meters per second squared. So what that means is that our velocity for the final should be higher than our initial because we're accelerating. So that's important to note. We'll check our answer at the end to make sure that's true. Delta T is going to be equal to 6 seconds. Okay. We're going to need some more space for this, so we'll do the work and answer a little bit further down. Okay, for our equation, A is going to be equal to VF minus VI times delta T. Well, we're solving for VF. So if we're solving for VF, we can use the other version of this equation. So when we rearrange this, we say that the VF is equal to our initial velocity plus acceleration times the change in time. So we can use this equation to solve for it. Okay. So our work, let's plug in. VF is going to be our VI, which is 25 meters per second plus our acceleration. For our acceleration, we have 7 meters per second squared times our time, which is 6 seconds. So if we multiply these two together, one of these seconds is going to cancel the square. So 7 times 6 gives us 42 meters per second plus 25 meters per second. So we add these two together, we get 67 meters per second. We know it's positive because it's going forward. And if we look at our problem, we knew it was accelerating so that our final velocity should be higher than our initial. So the final 67 is higher than our initial.